Hi all, this is lecture 14 on section 3.5, graphs of functions. So we want to pick up the last couple of functions we haven't talked about yet, which is our absolute values and our piecewise functions. So with absolute values, what we want to do is we were going to graph our function as if there were no absolute values, okay? And then we're going to reflect the part that is negative across the x-axis to make the values positive. So for example, here in number 1, we have y equals x, absolute value of x minus 3. Okay. Now, if we take away the absolute value, that's y equals x minus 3. And so we're going to go ahead and graph that. So here's my coordinate plane. And this is a line, and its intercept is negative 3, is our y-intercept. And my slope is the number sitting in front of the x, which is just a 1. So I'm going to go to negative 3 on the y-axis. And remember, your m equals 1, that's 1 over 1, and that's your rise over your run. So we're rising 1 and going to the right 1. Up 1, right 1, up 1, right 1. And I'm going to go ahead and graph that. Okay. Now, that is the line of y equals x minus 3. Now, absolute value of x minus 3 would take anything that's negative below the x-axis and flip it up. So I'm going to keep this part over here, so that remains here, including this point at 0. And then I'm going to reflect that up this way, as straight as I can. Sorry, it's not perfectly straight. And so the red one is your y equals absolute value of x minus 3. Now, for example, 2, I gave you the same one, so let's go ahead and change that. Let's do y equals absolute value of x squared minus 1. Okay. Now, x squared minus 1 is a parabola that opens up, and we didn't do a whole lot with how to graph these without a little chart, so let's go ahead and do that. So first, we're going to graph y equals x squared plus minus 1. So exactly what the equation says, except you're taking off the absolute value. So if we create an xy chart here, 0, 1, 2, negative 1, negative 2, and we'll see what happens. When I plug 0, it's negative 1. 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1 is 3. Negative 1 squared is 1, minus 1 is 0. And negative 2 squared is 4, minus 1 is 3. So if we go ahead and graph that, I get 0, negative 1, so I get a point down here. And then I get 1, 0, and negative 1, 0. And I get 2, 3, and negative 2, 3. And so I get a parabola that looks like this. Okay. So now, if I want the absolute value, I'm going to keep everything that's above the x-axis. So here's where it touches the x-axis. So I want that and what's above. And then what I'm going to do is the part that's below, I'm going to reflect up. So this point down here becomes this point up here, and I get the little curvature here. So the red one is my y equals absolute value of x squared minus 1. Okay, so we just reflect it and make it positive. Okay, so that's your absolute values. When it comes to piecewise functions, it's a little bit different. What we're going to do is we're going to break our graph into sections, and we're going to graph each piece only on the section where it's defined. Okay, so here's a piecewise function, and we're going to graph this. Okay, so let me start with my coordinate plane. And I'm going to think about dividing this into different sections. So we have less than negative, x is less than negative 1. So here's negative 1. And then I want to go from negative 1 to 0. Then I want to go equals 0 and then bigger than 0. So I have 3 kind of sections that I'm going to work in. So we have this section over here from less than negative 1. I've got this section in the middle that is between negative 1 and 0. And then we have this section over here that is bigger than 0. Okay, so I'm going to graph something different on each section. in the yellow section, I'm going to go ahead and graph this top one because that's what's going on here. So y equals 6x minus 1. So that's a line where the y-intercept is -1. And then I can use the slope. Now, what I'm going to do differently here is instead of going to the y-axis, because that's not in my yellow section, I'm going to take the breaking point. So at -1, what happens at -1? So x and y values at -1, I get 6 times -1 is -6, minus 1 is -7. And I'm going to choose one other one just because -2 will give me -12 minus 1 is -13. So I can graph those two. So -1, -7 would be this point. And -2, -13 is going to be way down here. And so it's this line right here. Now I'm only extending that into the yellow section. Then between -1 and 0, I'm working with x squared, y equals x squared minus 3. And that's in the blue section. So I'm going to go from -1 to 0. So I'm going to use a couple of points in here. So x and y. -1, I'm definitely going to use 0. So if I plug in -1, -1 squared is 1, minus 3 is -2. Plug in 0, that's -3. So at -1, it's -2. Now I have to be careful here, and I'm going to back up for a second. In the yellow section, notice that that was an or equal to. That means that this point is not going to include, I'm going to use an open circle here where I had that point, okay? And then at the -1 in the blue section, at -1, -2, I'm going to use a closed circle. At 0, because this one is not or equal to, I'm going to use an open circle. And the point there is 0, -3. So it's going to look like this. I'm just going to connect those up as a little parabola. Then at the point for 0, if you plug 0 into the 6x to the 7th plus 5, we get 5. So 0, 5 is my point. And then for things larger, I always get 3. So at 0, I'm going to put an open circle at 3, and it's going to stay at 3 the entire time. So that is my graph, and it looks a little bit interesting, but let me kind of highlight it a little bit better for you. So we've got an open circle here and down this way. Closed circle here, open circle, closed circle, open circle, graph, right? So 4 different pieces. And let me show you one more of those. This one has 3 pieces. So we're going to start with our graph, our coordinate plane. And notice my breaking points here are at -1 and 1. So I'm going to have -1 and 1. And I'm just going to draw dotted lines this time so that maybe it doesn't look so involved. And then I'm going to see what happens. So for 2x plus 5. So for x less than or equal to -1, or y equals 2x plus 5. If I plug in -1, if I plug in -1, that's -2 plus 5 is 3. Now this is or equal to, so that's a closed circle at -1. So -1, 3. Would be up here. And I'm going to use the slope this time. So the slope here is 2 over 1, and that's my rise over my run. Now, normally I would go up 2 and right 1, but if I go to the right, I'm going to be in a different section, and I want to be towards the left. So instead, I'm going to reverse that. I'm going to go down 2 and left 1. And that's where my line's going to be. Okay. For that middle section, we have y equals x squared. And y equals x squared, if we test a couple points, 0, 1, actually, yeah, 0, 1, and -1. Let's do that. Let's see, 0 is going to give me 0, 1 is going to give me 1, -1 is going to give me 1. Now, keep in mind that these are both strict inequalities, so I'm going to need open circles at those 2 points. So at 1, 1, and at -1, -1, and 0, 0. So I'm going to have these points here. And then in my last section, for x is greater than or equal to 1, we have that x equals 2. So that's an or equal to. So at 1, the value is 2. And it's going to remain 2. So I'm going to be horizontal. Okay, and those are my 3 pieces.